My dear student, I am A.K. HAZRA from Salt Lake City, Kolkata. I wholeheartedly welcome you to School of Fundamental Sciences for our confidence building program. This intensive program will help you a lot to understand the fundamental concepts of physics, chemistry, mathematics steadily. I earnestly request you to study the content of our videos very carefully. I will be happy if you understand and enjoy the useful concepts. My heartfelt wishes for your bright future. Thank you. My dear student, let us explain mole concept in very important concept of chemistry. So mole concept, I am discussing mole concept. Mole concept has different views. So first view, in terms of number. Now 1 mole, symbol MOL, is defined as the amount of the material that contains number of elementary particles. Elementary particle means atom, molecules, ions, etc. Same as the number of C12 atoms in 12 gram C12 isotope. Actually 1 mole of C12 equals to 12 gram, and number of C12 particles in 1 mole C12, that is 12 gram C12, equals to Avogadro number. So if you have any substance and corresponding amount, if contains the number of particles equal to the number of C12 atoms present in 12 gram C12 isotope, that is the Avogadro number. So this number is called Avogadro number or Avogadro constant, symbol is Na, and experimentally it is found that Na equals to 6.023 10 to the 23 dimension particles per mole, because 12 gram C12 is called 1 mole of C12. So 1 mole C12, that is 12 gram C12, contain 6.023 10 to the 23 particles. That's why its dimension will be particles per mole. Now you see some examples and you can realize. Suppose if I say 1 mole of oxygen atoms, so it must contains 6.023 10 to the 23 oxygen atoms, because it is the number of atoms in 1 mole oxygen. If you say 1 mole of O2 molecules, it must contain 6.023 10 to the 23 O2 molecules in 1 mole, you see please. Similarly, if you say 1 mole of electrons, obviously it must contain 6.023 10 to the 23 electrons. Similarly, if you say 1 mole of H3O plus ions, it must contain 6.023 10 to the 23 H3O plus ions. So in terms of number of particles. Now next, second view. The second view, you see the in terms of mass, actually 1 mole, symbol is 1.00 mole. Atoms of a substance is defined as the amount of the substance that has mass equal to relative atomic mass. Already you have explained relative atomic mass, U per molecule, but here it will not be U per molecule, it will be gram per mole. Let us see how. Mass equal to relative atomic mass expressed in gram. Old idea is what? 1 mole atoms is called gram atom. Now it is backdated. You say very clearly, you will say 1 mole atom. If you have a molecule, 1 mole molecules. If you have ions, 1 mole ions, like that. You see an example. For example, 1 mole of nitrogen atoms weighs 14 gram. Why? Because its relative atomic mass is 14 U per atom nitrogen. I will explain how this U becoming gram and 1 atom nitrogen becoming 1 mole nitrogen. Let us see, which can be explained as follows. Let us see. Mass of 1 mole of nitrogen equals to what? Already we have defined 1 mole. Mass of 6.023 10 to the power 23 nitrogen. It is notation of nitrogen atoms, already written, nitrogen atoms. So 6.02 is equal to, what is the mass? Mass of 6.023 10 to the power 23 nitrogen atoms equals to 6.023 10 to the power 23 nitrogen atoms into 1 atom has the mass 14 U per atom. So 1 atom has the mass 14 U in U scale, atomic mass unit scale, but it is to be converted into gram. We know 1 U is equal to 1.66 10 to the minus 24 gram is equal to 14 gram. Why? Already I have explained. You see, 1.66 10 to the minus 24 gram equals to 1 by, you see first review, 1.66 10 to the minus 24 gram is equal to 1 by Avogadro number. This is equals to 1 by 6.023 10 to the power 23. And that's why 6.023 10 to the 23 into 1.66 10 to the minus 24 gram, already you have explained, is equal to what? 6.023 into, it is equals to 1 by 6.023 10 to the 23. So it is already equals to 1. So 1.66 10 to the minus 24 gram in AMU scale actually equals to 1 by Avogadro number. That's why when Avogadro number is multiplied, it becomes 1. That's why you see 6.023 10 to the 23 nitrogen atoms. Now 1 nitrogen atom, yes, weighs 14U, and 1U corresponds to 1.66 10 to the minus 24 gram. So clearly this and this equals this and this equals to what? 1. So ultimately we will have what? 14 gram. Nitrogen atoms, nitrogen cancel out, U cancel out, only gram 14 gram. Yes. Similarly, you see, if I say molecule, first one in terms of atoms, now in terms of molecules, same concept. 1 mole of molecules of a substance is defined as the what? Number of substance that has the mass equal to relative molecular mass expressed in gram. Old notation is what? Gram per molecule. Nowadays it is called only simply mole. 1 mole of molecules is called 1 gram molecule. Old concept. Now it is simply 1 mole. So 1 mole of N2 molecules contains 28 gram, because why? Relative molecular mass of nitrogen is what? 20 U per molecule. So please you see 20 U per molecule becoming 28 gram per molecule N2. 1 molecule becoming 1 mole N2, 28 U becoming 28 gram. Again see, already explained. Mass of 1 mole of N2 equals to what? Mass of 6.023 10 to the power 23 nitrogen molecules. So what is the mass? 6.023 10 to the 23 nitrogen molecules, and 1 molecule, yes, 28 U per molecule, because relative molecular mass is what? 20 U per molecule N2. So 28 U by 1 molecule N2. Now expressed in gram, we know 1 U 1.66 10 to the minus 24 gram. Again you see please, 6.023 10 to the 23 into 1.66 10 to the minus 24 gram equals to 1. So ultimately 28 gram. This the message is given, same concept. You see, if you have relative atomic mass 14 U per atom nitrogen, for example, or simply you can say 14, but actually 14 U per atom, in it is a relative atomic mass. So then what is the atomic mass of nitrogen? 14 U becoming 14 gram, 1 atom nitrogen becoming 1 mole nitrogen. So be careful, relative atomic mass always 14 U per atom, but if you have atomic mass, it is a gram per mole atom. Similarly, relative molecular mass RMM and molar mass mm. So relative molar mass, you see the numerical values of relative molecular mass and the molar mass same, but dimension not same. Be careful. Relative molecular mass of nitrogen is what? 20 U per molecule N2. Only 1 molecule, 28 U, or simply 20 U. But if I say molar mass of nitrogen, it will be mole concept, 28 gram per mole N2. 28 U becoming 28 gram, 1 molecule of N2 becoming 1 mole N2. 28 gram per mole N2. Now you see sample problem number 06. Relative atomic mass of carbon. If the relative atomic mass of carbon were set at 120, not 12, be careful, 120. Question is then find the value of Avogadro constant. What is given? Avogadro constant in the C12 scale, we know 6.023 10 to the 23. So if we have this scale, that is the relative atomic mass of carbon is set at 120. So what will be the Avogadro number? Yes, solving this problem, you see, in the new scale, C120 scale, Avogadro number or Avogadro constant will be the what? The number of C120 atoms in 120 gram C120, because 1 mole of C120 equals to what? 120 gram. Avogadro number always number of particles per mole. So in the scale C120, so it is clear that 120 gram C120 means what? 1 mole C120. So number of C120 particle in 1 mole C120, that is 120 gram C120 will be the Avogadro constant or Avogadro number in the new scale. So Avogadro number in the new scale or Avogadro constant in the new scale equals to what? That we know. It is true, experimentally obtained 6.023 10 to the 23 carbon atoms per 12 gram carbon. That already we have defined. Truly it is actual Avogadro number or Avogadro constant. 12 gram carbon contains 6.023 10 to the 23 carbon atoms. So we will convert into what? 120 gram. How? 6.023 10 to the 23 carbon atoms by 12 gram carbon. Now we need what? 120 gram. So 120 gram carbon by 1 mole carbon in the new scale. So ultimately we will have 6.023 10 to the 23 10 to the 24 because 12 cancel 10 6.023 10 to the 24 atoms per mole. This is the what? This is the 6.023 10 to the 23 carbon atoms in 12 gram. We need number of carbon atoms in 120 gram. So how? Now because you know 120 it is a per gram carbon factor level concept. Now for 120 gram carbon by 1 mole carbon, it is a what? Atoms per gram carbon multiplied by, you can think in this way also, into 120 gram. So we will find the what? Number of carbon atoms in 120 gram carbon means in 1 mole carbon. That is the new Avogadro number in the new scale. Now here we have considered carbon atoms, but general Avogadro number is what? Not only carbon particles, any particles. So 6.023 10 to the power 24 particles per mole. That is the new Avogadro number in the new scale. Next problem, if one atomic mass unit is taken as 1/6 in place of 1/12, already we have defined 1/12, but if we take 1/6 the mass of C12 atom, then we have to then compute the mass of 1 mole of carbon dioxide. So in the new scale, what is the mass of 1 mole of carbon dioxide? So you see solution in the new scale, what is defined? 1U is equal to 1/6 into mass of 1 atom of C12, not 1/12, be careful. Then the relative molecular mass of a substance in the new scale is what by definition? Relative molecular mass in the new scale, mass of 1 molecule of the substance, it is always true. That is mass M substance means mass of 1 molecule of the substance divided by not 1/12 but 1/6 the mass of 1 atom of C12. Now it can be manipulated as what? 1/2 into mass of 1 molecule of the substance by 1/12 into mass of C2 one atom of C12. 1/6 2 and 1/12 cancel out. Is 1/6. The half is multiplied, so it will be what? 1/12. So clearly half into it is the what? The relative molecular mass in the old scale, that is our original scale, not the new scale. So half of relative molecular mass in our old scale. So relative molecular mass of CO2 in the new scale equals to what? Half of relative molecular mass of carbon dioxide in the old scale. Is equal to 1/2, and on the old scale what is the value already given? 44 U per molecule. So we will have 22 U per molecule in the new scale. So mass of 1 mole of carbon dioxide in the new scale is what? Molar mass of carbon dioxide in the new scale. 22 becoming 22 gram, 1 molecule becoming 1 mole. So 22 gram per mole in the new scale. Now next, SP08. 3.17 10 to the power 21 molecules are removed from 352 milligram of a gas of molecular mass 38. But be careful, molecular mass 38 means actually it is 38 gram per mole. Be careful. Just casually we can write 38, but truly speaking it is 38. Accurately speaking, 38 molecular mass gram per mole, or you can say U per molecule. Now compute the mass and the amount of the gas left. Solution. So mass of 3.17 10 to the 21 molecules equals to 3.1. We are solving problem by factor level concept. 3.17 10 to the 21 molecules. Now convert into mole. How? 1 mole, we know 6.023 10 to the 23 molecules. So molecules cancel out mole. Now already given 38 means what? 38 gram per mole. So use conversion factor 1 mole 38 gram. So mole cancel 38 gram. Convert to milligram, because milligram is 352 milligram is given. That's why convert to milligram. So 1 gram 1000 milligram. So gram cancel milligram. 200 milligram you calculate, it will be 200 milligram. So mass of the gas left 352 milligram originally present minus 200 gram taken away, so 152 milligram answer. Now amount of the gas left, it is a mass and amount. Amount means obviously mole or millimole. There is a milligram, so we can have in millimole. So 152 milligram, and yes, what is the molar mass? 38. Please you see 38 gram per mole or 38 milligram per millimole. Same. 38 gram per mole. If you multiply 1000 it will be what? 38 milligram per millimole. So 38 milligram 1 millimole. So milligram cancel out. We will have millimole. So 4 millimole answer. Now SP09, mass of one atom of an element is this gram. Now compute the number of mole of atom of the element in 40 kg of it. As you see, first let us find the atomic mass of the element. Atomic mass of element, atomic mass 6.44 10 to the minus 23 gram per atom is given. One mass of one atom is given. So 6.44 10 to the minus 23 gram by one atom. Now we will convert into what? Mole. Atomic mass means what? Gram per mole. So convert into mole. How? Now 1 mole atom is equal to 6.023 10 to the 23 atoms. Atom cancel, we will have gram per mole atom. Mole means mole atom, understood. So it will be 40 gram per mole atom. So required number of mole, now we are going to find required number of mole atom present in 40 kg. So 40 kg convert into gram, 1 kg 1000 gram, so kg gram, and we know the conversion factor 40 gram per mole atom. So 40 gram 1 mole atom. 1 mole atom is equal to 40 gram equal, so this by this is also 1, and 40 gram by 1 mole atom also 1. But we need what? We have to cancel gram, we need mole atom. So clearly 1 mole atom by 40 gram. Kg cancel, gram cancel, we will have 1000 mole atom answer. Now SP10, hemoglobin contains 0.25% Fe by mass, iron by mass. The molar mass of hemoglobin is given 89600 gram per mole. We have to compute the number of iron atoms, Fe atoms per molecule of hemoglobin. The relative atomic mass of Fe is given 56. But be careful, it is actually 56 U per atom, or in mole concept we can say 56 gram per mole atom. Be careful. Now, mass of Fe in 1 mole of hemoglobin. Hemoglobin symbol I have used HAEM, hemoglobin. What is given? 0.25 gram Fe present in 100 gram hemoglobin, because 0.25% iron by mass. So 100 gram hemoglobin contains 0.25 gram Fe. That's why I have written 0.25 gram Fe per gram hemoglobin. That is divided by 100 gram hemoglobin. But its molar mass is given 89600 gram per mole. So convert into mole. 1 mole hemoglobin 89600 gram hemoglobin. So clearly gram hemoglobin will cancel out. We will have what? 224 gram iron per mole hemoglobin. So 1 mole hemoglobin contains 2 to 4 gram of iron. So amount of Fe in 1 mole hemoglobin, 2 to 4 gram iron by 1 mole hemoglobin already obtained. Yes. So amount of iron is a gram iron, but we need mole iron. How? Already we have calculated 2 to 4 gram Fe per mole hemoglobin. Now we have to convert this on mole iron. How? Mole Fe already given. Relative atomic mass given 56. 56 means what? 56 gram per mole Fe atom. That I have written. 1 mole Fe, 56 gram Fe. So gram Fe cancel out. We will have mole Fe per mole hemoglobin. So 4 mole Fe per mole hemoglobin. Also equivalent to what? 4 atoms Fe per molecule hemoglobin. Because here also it is also what? 4 into 6.023 10 to the 23 divided by 1 mole hemoglobin means 6.023 10 to the 23 hemoglobin molecules. So ultimately Avogadro number cancel out. So we will have 4 atoms Fe per molecule hemoglobin answer.